ever since I did accounting systems, and I did, I think, 3 in my life, they were full of redundancies. For every single journal entry we got, we went to total records, materialized aggregates, per customer, per supplier, per ledger, per various general ledgers, material ledger, et cetera, and updated debit and credit per month, totals per month. And if you ask us that you're in a different business, then we give you weeks. Actually, I started thinking about how about days? Isn't that better? And then the students said, why not no aggregates? And then we started to evaluate this. The first answer is, this can never work. I'm as conservative as many others. But when you get then from the SAP an information that comes on the next chart here, I have to, yes. That, by the way, I just let you know, our lab test of T-Rex showed that T-Rex scales linearly with number of blades and linearly with the number of cores per CPU on a blade. That has to read number of cores per CPU on a blade. This is measured, and then if this is true, let us really look into a real system and calculate what is happening in a real system. So there's supply chain, there's SRM, CRM, financials, etc. There's all of a sudden enough memory on one or more blades. And then we find out with research, and there are papers, there's an HPI booth here, and they have papers, there are probably 20 or more papers, and you can read them. This is science, this is available. And many other people have written about this, by the way. Only a few columns in these commercial applications have many distinct values. So in millions of records, we have a country. But there are only 200 countries in the world, 200 plus. In every single record, there's a currency, but there are only 100 plus currencies in the world. In every single personnel record, there's a sex, female, male. There are only 2. And even if we are, then there are only 4. So we have only a few distinct values in many columns. This is something for the computer scientists. They compress these spaghettis to very, very, very small size. So the compression is a factor 10. We had this already. Then you can come to a conclusion easily. Only relevant data should be in direct access here, or on the RAM access. A little research shows that the average SAP customer has between 7 and 10 years of data history online on disk. When we started, we allowed our customers to have a quarter. We were hard-pressed in the 80s to achieve a year. And now, in the 2000s, including SAP, we have between 7 and 10 years. Let's take the current year, everything what happened this year, and everything what spilled over from last year, what has to be handled this year, into our current database. This is 1/7 or 1/10, a little bit more than 1/7 or 1/10 of the actual size of the database. I give you a 7, a factor 7. We can save. The rest goes to flash. It's a little bit slower. We saw this, 5,000 CPU cycles, but still, I cannot calculate it fast enough. Still 200 times faster than to travel to the Mars, to go to disk. So this is gone. Then these, I don't get enough time from Marty Homlish, our head of marketing. to explain to you why this data structure is so good for partitioning. But let us assume it is. The guys who built the database can partition in any direction nicely. So one table goes across multiple blades. And we have removed the redundancy. Actually, a good business suite financial system stores the same data, a journal entry, 4 times. We store it once, then some of you have not only 1 journal ledger, they have 2 journal ledgers. In Italy, they have 4. Sorry, Italians. But I learned this, it's true. There are 4 journal ledgers. And then we have a cost center ledger. This is a European invention that we run the cost center accounting in a separate circle and not directly inside the general ledger. So we have redundancies. You know why we have these redundancies? Only for speed reasons. We were sitting together. This was done by Henning Kagermann. Actually, I'm sad that he didn't come here. On Wednesday next week, he's retiring, so he probably didn't want to be here and have a farewell tour. Comes later. But we made the decision that we have redundant data because this is faster. We get rid of this, gives us a factor 2. So we have 7 by relevant data. We have a factor 2 by no redundancy. That is 14. We have a factor 10. This is 140. I make the promise, if you tell me you have 100 terabyte, then I say I compress this down to, give me 2 terabyte. And you heard already, with 10 of these type, next generation, I can do 5. So there is enough capacity. Let's do it. The binary strings, that was, oh, it comes a little bit later. So the strings are binary, highly compressed, extremely suitable for the new CPUs. What the Java guys did not understand is that we programmers have to understand how a computer works. I had endless debates with Scott McNeely about this. He is not an engineer, but Harvard. So, first class. I said we have to know how a computer works. Actually, you have to feel a little bit how a CPU works. And when you look at today's SAP system, or you look at the new SAP system, which we build with more layers, we call this abstraction layers, then the #1 thing what the CPU is doing is moving things around. It's not doing any business, it's just moving things around. Just moving around. And that is costly, heat, slow, and not productive. We can remove that. Actually, we do not store data in intermediate stores anymore. We do not cache data. We don't have indices on structures. We just access data every time freshly from the database, because the database is anyway in memory. When I explained this schema to John Hennessy, who is president of Stanford University, a week ago, or 2 weeks ago now, he said, quote unquote, if you pull this off, that is huge. And he fully understood what we are up to.